Okay, in 61C, it's different than the other problems because we have HCl and NaOH, which are both strong, and B and A both had something weak. So for the halfway point, we knew pH equals pKa, but that's only true for weak things, so it does not apply here. Okay, so at halfway, we actually need to just figure it out. So we have H plus OH minus makes H2O because I get rid of the Na and the Cl. Okay, and then I'm going to Becca because I'm going to have some of this and some of this. So two things on one side. I know I have to Becca. I have 0.1 times 0.5, which is 0.05 moles. So halfway I would have 0.025 moles of OH. So I'm going to lose all of the OH, and I'm going to lose it from the H also, so that I will have 0.025 moles here. So it would add over to the water side, but we don't care about water. And now that I have H+, all I need to do to find the pH is the negative log of the moles divided by the liters. But I have to think about the liters. I had 100 milliliters, but I had to add enough OH to get 0.025 moles. So I would need to calculate 0.025 moles equals the molarity, which is 0.25 moles over liters, times X liters. So we end up with 0.25x equals 0.025, and you would divide and you'd solve that x equals 0.1 liters. So I had 0.1 liters of acid and I had to add 0.1 liters of base, so I'm dividing by 0.2. And when you solve for the pH, you find that the pH is 0.89. And it makes sense. We had 100 milliliters of something stronger, so to get halfway we needed 100 milliliters. To get all the way we would need 200 milliliters of the sodium hydroxide. Then at equivalence, that's actually easier. At equivalence points, we could Becca, we would see that we would have 0.05 and 0.05 because they're equal. These are both going to go down to 0. And it would add to the water side, but we don't care, it's water. Which means that at the equivalence point, the pH for strong and strong is just equal to the pH of water, so pH equals 7.